Okay, how do we go about to solve question 8? Okay, two forces act on a 2 kg mass as shown below. Okay, question asks for the acceleration of the mass. Okay, acceleration is represented by the symbol A. So try to recall the formula that can help to solve this question. Okay, the first thing that I notice is that there are two forces acting on the same object and they are in opposite direction. So with two forces, I can actually represent it with one single force called resultant force. So the first part to solve is applying this concept of resultant force. F is equal to, because there's more force acting to the right, so in this case this resultant force F will be also to the right, and I take the bigger number minus the smaller number, which is minus 3, because these two forces are acting in opposite direction. So in this case I get 4 Newton, which is acting towards the right. So this is my resultant force F. But we are trying to find acceleration. Okay, acceleration. So is there another formula relating to acceleration? I can recall there's another formula called resultant force F is equal to m times a. So with this second relationship, I can actually substitute values inside. Okay, so how do I substitute? My F is actually 4. Okay, and my mass of this object is actually in the SI unit of 2 kg. So 2 times A. So A is actually equal to 4 divided by 2. So my answer for acceleration is 2 meter per second squared. So the answer for question 8 should be A. Okay, so you can recall there are 2 steps to solving it. Okay, let us now move on to question 9. Okay, question 9 is on the topic of, if you notice how there are physics, there are so many topics. How do we recall which topic? Okay, if you observe, first part is this part. There's actually this thing called a pivot. Okay, pivot. With a pivot, we have to recall the topic of turning effect of forces or moments. Okay, so the next keyword to notice is equilibrium. What do I mean by equilibrium? Means when my rod is hang, it should remain totally horizontal, okay, or otherwise known as balance. So when you look at all these, analyze the diagram, and look at the keywords, it's actually talking about when will the principle of moments hold true. What does principle of moment says? It says that the clockwise movement, the sum of the clockwise movements about the same pivots will be equal to my sum of my anti-clockwise movements about the same pivot. Okay, so how do we find moment? So first let us look at the force of 1 Newton, where its force is actually pushing it down. So when it's turning about this pivot, okay, I can identify this as actually my, in this case this is actually my, it's turning in the same direction of the clock, so this is called my clockwise movement. Okay, so there's a clockwise movement 1 that's created by this 1 Newton force. So let's look on the left. There's a 3.5 Newton weight acting down, so it will turn about this pivot. So when it turns, it actually gives me my anti-clockwise movement. Okay, so this is my anti-clockwise movement, which is turning in this direction. So let's try to look at the anti-clockwise movement. Okay, so let me open up okay, let me try to always go back to the same page, but let me open up another page first so that I can recall. So there's a, how do we find the clockwise moment? Clockwise moment is the force multiplied by the perpendicular distance from the force to the pivot. So I will take, in this case, okay, so my clockwise moment, if I calculate, my clockwise moment is actually equal to my 1 Newton times my 1.2 meter. So my clockwise moment in this case is 1.2 Newton meter. So to help me to remember direction, it's actually pointing in this direction. Okay, let me now look at the on my left, which is my anti-clockwise moment. So my weight is 3.5 and my perpendicular distance is actually 0.4 meters. Okay, so I will take my anti-clockwise moment is actually equal to my, okay, you can't recall, go back, it's actually 3.5 times my 0.4 meters per panel distance. So if I press my calculator, okay, I will get an answer which is 1.4 Newton meter. Okay, if we do a comparison, this is 1.2 Newton, which is my clockwise moment, and my anti-clockwise moment is actually 1.4. So in order for it to be in a state of equilibrium or balance, these two are supposed to be equal. So what is, if we take the difference, actually this clockwise moment is still short of how much? It's actually still short of 1.4 minus 1.2, which is 0.2 Newton meter, which is supposed to be a clockwise direction. Remember, clockwise it has to be the same, so I'm still short of this. Okay, so the question now is, how can I make it balanced to get 0.2? Okay, so which way is required and where should it be placed? Recall just now we are short of the clockwise moment, which is 0.2. So we must find something that can take the force, in this case my force, which is my weight, multiplied by my distance, which is 0.2. So the possible answer in this case is actually option A, 1 times 0.2 is 0.2, or option C, which is 2 times 0.1. So how do we decide which is the answer? Okay, weight is always acting down. This is very important. So if I have a weight that's acting down, in this case, it has to be in the clockwise direction. Okay, acting down. So it has to be in the same direction as this part. Okay, acting down. So the best answer in this case is to the right of the pivot, which is on the right here. Okay, so this is the one that's missing. So my answer is supposed to be 2 Newton, and I need this distance to be 0.1. If you're not sure, just take 2 times 0.1. I'll get back the difference, which is 0.2. So the answer will be C for question 9. Okay, so let's now move on to question 10. Okay, question 10 is actually a question on density. How do I know? Because I focus on the key question, which is called density. Okay, so first let us try to recall the formula to find density. So density is actually equal to my mass over volume. Okay, some students can remember this formula easily. Okay, other students might find this triangle a bit easier to remember. Okay, so if it's a triangle, the mass, we always take the one that's on top. So the mass will be on top, and the density and volume, okay, in this case the density and the volume in this case will be below. Okay, how do you apply this relationship? You want to find density, I just cover density. So my mass will be, take this division sign, mass over volume. So this is actually a very useful triangle to remember to relate to density. So let's go back to the question now. Okay, so we are finding density. So we need the mass of the object and we need the volume of the object. Okay, so do we have the mass now? Okay, so we read the question now. It has a mass of 800 kg. Okay, you notice if you are looking for density, the options are all in kg per meter cube. This is very important. So if the unit of density is in kg per meter cube, means the mass has to be in kg unit, and the volume has to be in cubic meters. Okay, then we substitute the values inside and find density. So in this case, I can straight away substitute my value, which is 800 here. Okay, 800, and my volume in this case is a wooden block. Okay, if it's a block, length times breadth times height will give me my volume. So in this case, my volume is actually equal to 1 times 1 times 1, which gives me 1 cubic meters. So in this case, I'll substitute my value 1 here. Okay, so if I take 800 divided by 1, I'll get back 800 kg per cubic meters. So the answer in this case will be option B, right? 800 kg per cubic meters. Okay, let's look at the last question on this page, which is question 11. Okay, it says when brakes are applied to stop a moving vehicle, most of the KE is converted into, okay, KE is actually motion energy. when a object moves, it will possess this kinetic energy. Okay, stop. You're trying to stop it. So in order to stop, you need to apply friction. Okay, brakes are actually friction. Frictional force is actually opposing the motion. So in this case, when you apply a lot of friction, for example, you start to rub your hands, creating friction, you actually generate a lot of heat energy. Okay, so most of the energy when you start to stop a moving object is actually to between the tires and the brake system, is actually a lot of heat energy. So the best answer in this case is option B. Okay, so this is very important. Okay, brakes is friction, creating friction to stop, and to slow it down is actually a lot of heat energy. So these are all the questions for page 4. Okay, we'll stop here.